Okay, in this video, I'm going to complete the practice logic quiz number 3. As I've said many times, your best bet to study for this quiz is to sit down and take the practice quiz on your own without looking at any materials, take it like a real quiz, and see how you do. And then figure out what you don't know and use that as how you study. If you didn't take my advice and you're watching this video anyways, then at the very least, for each question, pause and attempt to do it on your own before watching me do it. First, let's start by previewing the whole quiz. So this quiz covers material, it says, from Unit 2, this is all the logic stuff, mods 2 through 4, but mostly proofs. That is accurate. As we'll see, you will ask to do a translation and a truth table, but most of it is proofs. Okay, the first 3 questions ask you to identify examples of arguments that have the form of our 5 argument patterns, and there will be 3 questions. So for this quiz, the practice version, we've got Modus Ponens, Disjunctive Syllogism, and Simplification. You'll see this kind of question on the actual quiz, but you may also be asked about modus tollens or conjunction. You'll be given 2 questions where you are given the justifications and you are asked to fill in the derived lines. And 2 questions of the opposite format where you're given the derived lines and you fill in the justifications. You'll be given 2 where you complete the whole proof. And then 1 3-part question. So question number 10, you're told that this is a valid argument. Your first step is to translate it into symbolic notation, and the translation requires that you put the argument in standard form and you provide a key. Next, you'll use the truth table method to show that that argument is valid and explain. So you'll construct the truth table and be able to explain how this table shows the argument is valid, which we already know, because we were told. And we'll also use the proof method to show that the argument is valid. Okay, let's start at the beginning. Again, be sure to pause and answer questions on your own. Okay, so which of the following are examples of arguments with the form modus ponens? Let's remind ourselves, what is this form modus ponens? It means we have a conditional statement, and I'm using Greek letters to signify that the antecedent and the consequent could be any statement, not necessarily an atomic statement. And we also have, as a premise, or because we've derived it, the antecedent of the conditional, and we infer or conclude the consequent of the conditional. So this pattern of reasoning is labeled modus ponens. You could do a truth table to show that it is a valid pattern of reasoning. So which of these are examples of this pattern of reasoning? Let's start with A. Do we have a conditional? Yes. Do we have the antecedent of that conditional? Exactly as it is. That's everything on the left-hand side of the horseshoe. Yes, we do. And have we concluded or inferred the consequent? Yes, we have. So this does have the form of modus ponens. We removed the parentheses note here because they are no longer necessary to disambiguate. Up here, if the parentheses had been here, it would be a different statement. So we need the parentheses, otherwise the statement's ambiguous. Down here, we do not need them. Without parentheses, there is no ambiguity. How about B? Is B an instance of modus ponens? Premise 1 is a conditional. Premise 2 is the antecedent of the conditional. The thing on the left-hand side of the horseshoe, identical. Have we inferred or concluded the consequent? Yes, this is identical. So this is an instance of modus ponens. And notice, in many ways, it looks different from this schematic. And this is why when advising you on how to think about the rules of inference based on these argument patterns, that you should use the sort of full wording of the rule and not just the schematic. The rule says if we have a conditional statement, and by we mean we're either assuming that it's true as a premise, or we have shown that is true by deriving it from the premises using truth-preserving inference rules. But so if we're assuming to be true, a conditional, and also the antecedent of that conditional, then we can infer the consequent of that conditional. That's what the rule tells us, and that's what this schematic represents. But use the full wording of the rule. Okay, we know that there are only two correct answers, so we can move on at this point, but let's be sure we can explain what the problem with C and D is, why these aren't examples of modus ponens. What is the problem with C? C we don't have a conditional. We have a disjunction such that one disjunct is a conditional, but we don't have a conditional on its own line, and that matters. So even though we have a conditional as part of this disjunction, and we have the antecedent of that conditional, and we conclude the consequent of that conditional, this isn't an instance of modus ponens because it's not on its own line. And that matters. And finally, D. Many students confuse D with modus ponens because it looks superficially more like the schematic than things like this do. But what matters and what's represented in the schematic is that we have a conditional and we have the antecedent of that conditional. Here we have a conditional, but this is not the antecedent and this is not the consequent. It's the other way around, and that matters. This is an invalid pattern of reasoning. It's possible the premises are true and the conclusion is false. Next, disjunctive syllogism. Again, pause, do it yourself. What is the pattern for disjunctive syllogism? We have a disjunction. We have the negation of one disjunct. It doesn't matter which one. I'm just going to pick the second one. And we conclude the other disjunct. We could have equally set up the schematic to look like this, or we could have set it up to look like this. The schematic only represents the fact that we have a disjunction and we have the negation of one of the disjuncts. This is the negation of not this, and vice versa. One is just as much the negation of the other as the other, if that makes sense. And it didn't matter which disjunct. So again, go with the full wording of the rule based on the argument pattern and not the schematic. Okay, so which of A through D are instances of disjunctive syllogism? We can immediately rule out A and B. Why? Because this one involves no disjunctions, and this one isn't good enough. It's a conditional statement whose consequent is a disjunction, but we don't actually have a disjunction. We don't know that a disjunction is true, and we're not assuming a disjunction is true. We do have the negation of one disjunct, and we've concluded the other one, but the problem is we don't have this on its own line. It's not its own premise. We don't know that this is true, and we're not assuming that this is true. That's what we need in order to have this argument pattern. How about C? We have a disjunction, so we're halfway there. Do we also have the negation of one of the disjuncts? Well, what we have is Y. Is Y the negation of one of the disjuncts? Yes, Y is the negation of not Y, and also not Y is the negation of Y. Have we concluded or inferred the other disjunct? Yes. So this is an instance of disjunctive syllogism. So we know this one, if there are no typos here, is not going to be an instance of DS, but let's be able to explain why. Oh wait. We said this one was a problem. We circled it because it was a problem. So we know this one is going to be an instance of DS. But we need to be able to explain why. Okay, so do we have a disjunction? Yes, we do. Is not Q the negation of one of the disjuncts? Yes, it is. Have we inferred the other disjunct? Yes, we have. Okay, so this one is an instance of disjunctive syllogism. Finally, simplification. What is the pattern for simplification? It says for any conjunction, again, phi and psi can be any statement. What matters is that the conjunction is the main operator. For any conjunction, we can infer, if we assume this is true, or if we know this is true, we can infer either conjunct, and I'm just going to randomly pick one. Alternatively, we could have represented this like this. We could have added tildes. The fact that it doesn't have tildes in the schematic doesn't mean there won't be tildes in instances of the pattern. What this pattern emphasizes is read the words of the Simp Rule. If you have a conjunction, you can infer, put on a new line, derive either of the conjuncts, either part of that conjunction. So which of A through D are instances of conjunction? Of simplification of this conjunction? Is A, notice that this is not a conjunction. We don't have a conjunction, so we can't simplify it. What about B? We do have a conjunction, so we're on the right track. Have we inferred one of the conjuncts? Yes, we did, this one. So this is a case of simplification. What about this one? We have a conjunction, sort of, but we can't say we have a conjunction where the main operator is conjunction. What we have is a conditional statement whose consequent is a conjunction, and we can't just take apart or infer pieces of a statement like parts of this conjunction, which is wrapped up in the consequent of a conditional. So, this is not an instance of simplification. Finally, D. Do we have a conjunction statement? Yes, we do. And have we inferred one of the conjuncts, either one? Well, one conjunct is N, the other conjunct is A or B. Have we inferred one of the conjuncts? Yes, A or B. So this is an instance of simplification. Question 4. Again, pause, try it on your own. And the number one thing to be looking at as you're doing this is the wording of the rules and not the schematics. The schematics are a representation of the rule, but they might emphasize things that aren't important, or you might read things into them that aren't important and miss what is essential. Read the rule. So the Simp Rule, the justification here is we looked at line 1 and we applied the Simp Rule. The Simp Rule says if you have a conjunction, you can infer either conjunct. So we're looking at line 1, which is a conjunction, and we're inferring one or the other conjunct. Well, which one? Is it not L, or is it N? Let's move on to the next line and see if it matters. This one says we're looking at lines 2 and 4 and using the rule DS. So let's look at lines 2 and 4 and see what we would need in order to apply the rule DS to lines 2 and 4. Well, 2 is a disjunction, and DS says if you have a disjunction and you have the negation of one of the disjuncts, you can infer the other one. And since it's applied to line 4, we need this to be the negation of one of the disjuncts. Not L is not the negation of one of the disjuncts, but N is. So up here we should have picked N. So we have inferred N from this conjunction. And now we're applying DS to lines 2 and 4, where we have not N or W. N, what does DS tell us we can derive? The other disjunct, exactly as it is. All right, line 3, or 6 as the case may be. It says look at lines 3 and 5 and apply MP. What does MP tell you? It tells you if you have a conditional statement, that's line 3, and you have the antecedent of that statement, that's line 5, you can infer the consequent of that statement. So G or L, and we're going to leave off parentheses when they are not required to disambiguate anything. If you include the parentheses, it'll get auto-graded as incorrect. Next, we're looking at line 1 simp. Hey, that's the same thing we did up here. Now, logically, there's nothing that says you can't get N again. It's just that we wouldn't need that. So, presumably, we're going to need the other conjunct. Finally, it says we're looking at lines 6 and 7 and applying the DS rule. DS says if we have a disjunction and we have the negation of one disjunct, we can infer the other disjunct. And that's G. And as a double check, the last line of your proof should be the conclusion we're told is the point to derive. Again, pause the video, try it on your own before watching me do it. Okay, so we know we're trying to get L and H. I could already fill it in here. And it makes sense. It says I'm going to use the conjunction rule. So probably I'm going to get L on a line and H on a line and use conjunction to put them together. So I kind of already know where I'm going, but let's just follow the rules since we're given them. This one says look at lines 2 and 3 and apply modus ponens. Modus ponens says if we have a conditional statement and we have the antecedent, we can infer the consequent and we leave off unnecessary parentheses. Next, it says look at line 4 and use the rule simp. Simp says if we have a conjunction, you can infer either conjunct. But which one? Is it L or is it not J? Let's just sort of keep that in our minds for a moment and move on. Line 6 says we're looking at 2 and 5 and using the conjunction rule. Well, to get what? We know we're going to either get B and blank or blank and B. And we know that it's either going to be L or not J is going to go in whichever version, but which one do we want? Let's see what the next thing says. Line 7 says, look at lines 1 and 6 and use modus tollens. Okay, so I know I want to use modus tollens on line 1. Line 1 is a conditional statement. Modus tollens says, if you have a conditional statement and you have the negation of the consequent, so we need the negation of this. And there's two things that could be. One could be this, but also this, although in this case, these would be unnecessary premises, or parentheses. So we need the negation of the consequent in order to apply modus tollens. And it says we're looking at lines 1 and 6. So we know that 6 needs to be L and B in order to apply modus tollens to lines 1 and 6. What does that tell us about the other line? So we said it was going to be this one or this one. It turns out it was this one, and that the thing we need to put in is L, which we got from where? line 5 was L, and we had already figured out that has to be either L or not J. Okay, so we have L and B. And what does Modus Ponens get us? We've got a conditional, we have the negation of the consequent, which means we can infer the negation of the antecedent. And technically, that could be either not H or H. Which one do we want? Well, H is part of our conclusion, and you aren't going to see any double tildes in anything, even though logically there's not a problem with it. So let's infer H. Finally, last step. It says we're looking at lines 5 and 7, and we're using the conjunction rule. Now, without knowing where we're going, that means we could either get this or this. And logically, there's a sense in which it doesn't matter that they will be true in all of the same situations, but let's get the conclusion exactly as it's stated. You'll need to in order to get this correct from AutoGrade. All right, that completes filling it in. Now notice how when there wasn't a definitive answer, we had to sort of move on. In general, it helps you can kind of switch mindsets between doing things you can see from beginning, just get started on the proof, to looking at where you're going and kind of working backwards. So just to illustrate that, let's quick work this one backwards. I know ultimately that I want to get this as the conclusion, L and H. And it says that 5 and 7 is going to be the conjunction rule, and this is a conjunction, so that means I'm going to have two things I make a conjunction out of, and those two things are L and H. So I know that 5 and 7 are going to be L and H respectively. I just don't know which one goes where. Now, I don't have anything else that I can figure out working backwards, so let's start with this. It says look at lines 2 and 3, use Modus Ponens. Modus Ponens will get me L and not J. As we determined last time. This line says look at line 4 and use simp. Well, I know line 5 here has to be either L or H. Which one can I get by simplifying 4? Well, we know it's L. It's the only option. So that makes this L, and that makes this one H. So now 2 and 5 conjunction rule. 2, 5, we know it'll be B and L or L and B. Which one do we want? Well, again, we have to look forward and see, well, which one do we want? What are we trying to get? If we're working backwards, we might look at, well, we're trying to get H. How do I get H? Well, let's look up in the premises. I see I've got a not H as part of a conditional statement, and I know that modus tollens is a way to get the negation of the antecedent of a conditional statement if you have the negation of the consequent. That's what I want. So that's what I'm going to derive here, and I can using lines 2, 5 in the conjunction rule. Okay, now let's fill in the missing justifications, which requires line numbers and rules. One thing you might do is, and I recommend this when you're doing proofs online, especially for the homework, but possibly in general, is write down the proof without the boxes or anything you're given. Just write down the original proof and work it on your own. I recommend doing it that way. And that might be a way of sort of helping you out. Now, if you're in a quiz situation and you're pretty good at proofs, you've done the work, you've practiced, and you're quick at doing them, then just do them online. But if you get stuck and you're looking at the computer version while you're stuck, maybe write it down with pen and paper and work the ones you're stuck on that way. Just don't hesitate to switch between pen and paper and computer. Okay, so one thing I'm going to do when I approach this is reason through it as if I wasn't given this stuff, just to get a sense of, this is kind of why I recommended maybe write it down and try it on your own without the hints. I know that I want this conclusion, so what I want is a conjunction. The first thing I'm going to do is sort of look up in the premises and see, is this conjunction anywhere in the premises, such that I could sort of disconnect it from something or derive it from something that exists already? And the answer is no. So how do you get a conjunction? Other than if it's like the consequent of a conditional, you could get it by modus ponens, hypothetically. But what's another way to get a conjunction? It's to make one using the conjunction rule. So I'm thinking I'm going to have to use conjunction to get, or on, A and not W, which means I want these. So how could I get A and or not W? Well, I already have not W on line 1, so how could I get A? So I'm looking up in the premises here for where is A. I do see a place where I've got an A. It is wrapped up in a conjunction that is part of a consequent of a conditional that is itself part of the consequent of a conditional. So what I'm thinking is, how do I get A out of this complicated statement? Whenever you want something that is in a consequent of a conditional, you should be thinking modus ponens. Modus ponens is how you get the consequent on its own line. Now, if we had the antecedent of that conditional, we could get this consequent on its own line as well. And if we had A and R on its own line, we could use simp to get A. So we have sort of a plan here, and having a plan for what you want can help you to figure out the justifications for things, right? So given my reasoning, I know I'm probably going to use conjunction on 2 lines. And since they're filled in for me, again, those lines are A and not W, I see I already have them, I can immediately fill in. I got this from 1 and 7. Next, I'm looking at, I want A. How did I get A? Well, when I was reasoning backwards, I was like, I'm going to do 2 applications of modus ponens, one to get this, and then simp it out of here. Well, we can see that I did manage to get conjunction on its own line, so this is going to be 6 simp. Now, how did I get this on its own line? Well, we'd said we wanted to get this on its own line, and it looks like we managed to do that. And how did we get this on its own line? Well, we said probably modus ponens, right? If we had R, we could get the consequent on its own line. So I'm assuming I got this by MP. And what would allow me to get that? Well, hey, here's that conditional, and here's the antecedent of that conditional that I got the consequent from. So 4, 5 MP. How did I get R? Well, where's R up here? R is up here, and it's also here. Hey, R is a disjunct and a disjunction, and we have a rule that allows us to get a disjunct on its own line. If you have a disjunction and you have the negation of one disjunct, you can infer the other. So 1, 3 ds. Finally, how did we get this? Lines 1 and 2, modus ponens. So that's a sort of working backwards approach to it. Now let's do it the sort of regular working forwards approach. There's lots of ways to think about these things. The most important thing you need to reason through it in any case is understanding how the rules work. If there's one thing to memorize, it's the wording of the rules, and then practice doing lots of proofs. Okay, so let's start with, what do we want? We somehow derived this. Let's just look in the premises for where this is. Hey, here it is. It is the consequent of a conditional. Whenever you want the consequent of a conditional, you should immediately be thinking modus ponens. And alternatively, you might have just seen it because there's 2 not W's next to each other. So this one is 1, 2 MP. Okay, if I had this, then what could I do? Well, it doesn't look like I can immediately do anything with this. I can't take it apart. I cannot use simplification on any part of it. If you're thinking I'll use simp on this to get out, you can't do that. You cannot simplify a conjunction that is part of a compound statement. You can only do it if the conjunction is the main operator. So the next thing I'm going to do is just look at what else I have to work with. I already did something with these two premises, but I haven't used this one yet. So let's just see if there's anything we can do here. We've got a disjunction. We have the negation of one disjunct. The other is R, 1, 3 ds. Okay, now what can I do? How could I get, I see that the thing I derived is not R. How could I get that? Well, where is it in my premises and derived lines? Well, it was in the original one, but then we got that part of that on its own line, and that has A and R in it. So I'm looking at this. And what I want is to get the consequent of this conditional on its own line. And there's a rule that allows you to do that, and that's Modus Ponens. If you have a conditional and you have the antecedent, you can get the consequent of that conditional on its own line. So 4, 5 MP. Next, I want A. How can I get A? Well, this is just sitting immediately above it, so hopefully you can see there's a conjunction, and A is one of the conjuncts, and I can just easily use simp to do that. There are A's elsewhere, but you can't use simp on any of those. Finally, I want to get A and not W. How do I do that? If this was part of, like, let's say this was A and not W, then you could use Modus Ponens to get this conjunction, right? It's not like the only way to get a conjunction is to use the conjunction rule. But if you don't already have this conjunction somewhere that you can separate out with some other rule, you're probably going to need to make it using the conjunction rule. And that means we need to have these two things on their own lines. Here's A, here's not W. Okay, again, try it on your own before watching me do it. Where should we start? So, one place that it often makes sense to start is if you see a conjunction, you might ask yourself, should I just simplify that off? In some of the proofs you'll see we only want one of the conjuncts and we don't just automatically simplify the other. There's nothing wrong with deriving something that is not necessary to get you to the conclusion so long as you apply the rules correctly, but you won't always need both conjuncts. In this case, it looks like we did derive both of them though. So 3 simp, 3 simp. Okay, now what? Well, somehow we got J or Z. The first thing I'm going to do is look at the premises and see if there's a J or Z anywhere. And the only thing that's close is up here. There's a not J or C that is the antecedent of a conditional. I'm immediately thinking Modus Ponens, and hopefully you are too. Why? Because what I want to derive, what I want to put on line 6 is the negation of the antecedent of a conditional, and there is a rule that allows us to derive the negation of the antecedent of a conditional. Modus Ponens says if you have a conditional and you have the negation of the consequent, you can derive the negation of the antecedent. So I would just need to have the negation of the consequent, and I do here. So I get this through 2, 5 Modus Ponens. Next, apparently I want not J. How could I get that? Well, I'm going to look for J's and not J's elsewhere in my premises and derived lines. So I see one here, but there's no way to get the negation of a disjunct out of a disjunction. I don't have any rule that it's like that, so that's not going to be relevant. Where else do I see J's? There's a J here, and there's a J up here. Well, again, what I want is not J, and what I have is a conditional whose antecedent is J. So I want the negation of the antecedent of this conditional up here. So again, I'm thinking modus tollens, modus tollens. I've got a conditional. If I have the negation of the consequent, I could get not J. Do I have the negation of the consequent? I do. Line 4. So 1 and 4 modus tollens gets me not J. Finally, line 8. How do I get Z? Where is Z? No, there's a Z here, and there's a Z here. Well, this I sort of decoupled out of this, so I'm immediately thinking this is the first place to look. How could I separate Z out of a disjunction? Well, we do have a rule that says that, so hopefully DS is popping into your head. We have a disjunction. We want to get one of the disjuncts on its own line, and in order to do that, we need the negation of the other disjunct, which we have. So 6, 7, DS. Okay, again, pause, try them on your own. Write them down with pen and paper. It's not that hard to transcribe. Do them completely on your own before watching me do it for you. Okay, there are 2 general strategies. Derive whatever you see, or try to work backwards. I'm going to do the work backwards strategy first. What I want is X and Y, so I'm sort of just going to sketch in, and this is why I recommend having pen and paper to sketch, so you can make a plan ahead of time. I want X and Y. And since there's no X and Y already in the premises together that I could like get out of something else, I'm probably going to use the conjunction rule to make this conjunction, which means I want X and I want Y. How do I get X and Y? That's what I'm looking for now when I look back to the premises. How do I get X? Here's an X. X is a conjunct in a conjunction, and I have a rule that says I can just break up conjunctions. So for line 3, I'm going to just do that. X, 1, simp. Okay, I got one of the things I want. Now I want to get Y. Where is Y in my premises? There's only one spot. It's the consequent of a conditional. I want the consequent of a conditional on its own line. Whenever I hear myself saying, I want the consequent of a conditional, I'm thinking modus ponens. If I had the antecedent on its own line, I could use modus ponens to get the consequent. So I'm thinking I'm going to get Y using modus ponens. How could I do that? Well, I would need to have the antecedent on its own line. So now I'm thinking, because I want to get Y, I want not Z. How can I get not Z? Well, not Z is part of a conjunction. So I'm also going to use one simp to get not Z. Good, I got this thing I want. Now I'm poised to get this other thing I want and use conjunction to put it all together. So I have a conditional on line 2. I have the antecedent of that conditional on line 4, so I can derive Y, the thing I want, the consequent of that conditional, using lines 2, 4, and modus ponens. So I finally got Y, the other thing I wanted, and so now I can put X and Y together using 3, 5 conjunction rule. And that completes the proof. So that's reasoning through it by working backwards, thinking about how to get what you want. The other strategy is to just do things you see. And this will often work well, especially for simple, shorter proofs. So I just look at the premises I have. Can I do anything? And if you're feeling stuck, just consult the wording of the rules and see if any of them apply. So we might go through this the long way, right? Like start with modus ponens. Modus ponens says if you have a conditional statement, I've got one, and you've got the antecedent, oh, I don't, okay, it doesn't apply. Modus Ponens says if you have a conditional statement, I do. And you have the negation of the consequent, oh, I don't. Doesn't apply. Disjunction says if you have a disjunction, nope, doesn't apply. The conjunction rule says for any two statements, you can make a conjunction. Well, I do have two statements, so I could derive the conjunction of these two statements if I wanted to, but I don't want that. That's a long, ugly statement that looks nothing like my conclusion. Okay, but of course, hopefully this is screaming at you. The first place to look might be just conjunctions. Simplify conjunctions. Just do what you see. And now we could go through that again. Does modus ponens apply? I've got a conditional. Do I have the antecedent? Hey, I do. So I can derive the consequent. Do I know if I'm on the right track to securing my conclusion? I don't know, but I can apply this rule, and as long as you can apply rules correctly, it's not logically incorrect. Now what? Well, this is where you have to remember where you're going. I want to get X and Y. What have I got so far? I just have been applying anything I see here. Hopefully you can see that once you've derived X and Y, you should put them together to get this conclusion. Okay, number 9. This one's a longer one, so we could do our work backwards strategy, or we could do the derive anything we see strategy and hope we end up at the conclusion. I'm going to start with the work backwards strategy. I know I want D. How do I get D? Well, where is it in the premises? Here's the only place it shows up in the premises, and it's the consequent of a conditional. So which rule should immediately be blinking in your head when you want the consequent of the conditional? Modus Ponens. So I'm thinking, I want D, and I'm going to get it by Modus Ponens. Now, in order to apply Modus Ponens to line 4, what additionally do I need? I need the antecedent. Do I have it? No, no, no. That means I need to get it. So now I want not A and not C. So that way I can use Modus Ponens on whatever this line is and line 4 to get D. So how do I get this? I look up here. Is there anywhere else I've got not A and not C? No, no, no. So I'm going to need to, I can't just unlock it or get it out of some larger compound statement. I'm probably going to need to make it. So I'm thinking conjunction, which means I want not A and not C. How could I possibly get those? Hey, I've already got not C. Whew, that's one thing I don't have to do. How do I get not A? Well, where else is not A? Well, not A is part of this thing, but I don't have anything that says I can get the antecedent of a conditional on its own line. I can only use a rule that'll allow me to get the negation of the antecedent on its own line. So that's not going to work. Instead, because I'm trying to use modus ponens, and I know I'm going to need to make this using the conjunction rule, I need to make this, not use this. Okay, so I'm trying to get not A. Where else is A? Well, here's an A. What I want is the negation of the antecedent of a conditional. So which rule allows you to get the negation of the antecedent of a conditional? Modus tollens. So I'm thinking I'm going to use modus tollens to get that. What would I need to have in order to apply modus tollens? I've got a conditional. Do I have the negation of the consequent? If so, then I can get not A using modus tollens. But I don't. I don't have not B on its own on any line, so now I want not B. But at least I see I'm getting closer. Here's a not B, and it is part of a disjunction, and disjunctive syllogism says if you have a disjunction and you have the negation of one of the disjuncts, you can infer the other one. So I'm on a path to get a thing I want. I've got a strategy in mind. All right, I'm going to move this out of the way. Here's my strategy. Let's start by getting this thing I just figured out, not B. So lines 2 and 3 allow me to get not B. Now that I have not B, I have the negation of the consequent on line 1. So I can use modus tollens to derive the negation of the antecedent. Now I have, what was the next? I was trying to get not B, got it. I was trying to get not A, got it. I already have not C. Why? Because I want to get this conjunction. So now I'm looking at lines 3 and line 6. I can get not A and not C. And I'm trying to make the antecedent here, so put them in the correct order so you have the antecedent on its own line. And why did I want that? Because I want to use modus ponens to get D. So now that I've got line 7, I've got a conditional, I have the antecedent of that conditional, and I can derive the consequent of that conditional. And that is the conclusion, which means my proof is done. That was my working backwards strategy, though of course we might have just tried the do whatever you see strategy. What's the first thing you see you can do? Well, if you get stuck, consult the wording of the rules. So just going through them in order. Is there a conjunction I can take apart? No. I can make a conjunction of anything, but do I want to? Probably not. Don't make a conjunction unless you know you want one. Modus ponens. Do I have a conditional statement? I do. Do I have the antecedent anywhere? No. Modus tollens. I have a conditional statement. Do I have the negation of the consequent? No, can't use that. Disjunctive syllogism. Do I have a disjunction? Hey, I do. Do I have the negation of one of the disjuncts? Hey, I do. A thing I can do, not B. Okay, so this opens some stuff up. Go back through the cycle. Do I have any conjunctions? No. Do I want to make any conjunctions? I'm not sure. Modus ponens. Do I have the antecedent of this conditional? No. Do I have the negation of the consequent? I do. So now I can use modus tollens. And this gives me a new puzzle piece to play with. What can I do with that? Well, this is the point where you need to know where you're going. Because I can go, can I apply modus ponens? Well, I still don't have A, so no. Can I apply modus tollens to anything? I already did that. There isn't anything left to do here. Can I apply disjunctive syllogism? Only to this. There's no more other cases of disjunctive syllogism. I already did that. Can I simplify anything? No, I don't have any conjunctions to simplify. Can I make a conjunction? Well, I can make a conjunction out of any two things I've got. Do I want a conjunction? This is where you need to remember where am I going and see that I have a conditional, that the thing I ultimately want is the consequent of that conditional, so I would need this conjunction in order to use modus ponens. So this is where I'm telling myself I need a conjunction. Once you say I need a conjunction, that tells you which conjunction to make. I need not A and C, and I have not C, and I have not A. And now I can use modus ponens, which was the thing I was just describing in my strategy. So that's the do things you see, but at some point you need to know where you're going, because you need to know which conjunction you want. Okay, translation. Step number 1 is just to spot operator words, so I have either a cat or a dog. If I have a dog, then I have a yard, but I don't have a yard, thus, that's a conclusion indicator word. I have a cat, and double check for negations. Did I miss any? I don't think so. So now I'm going to select my atomic statements. So I see I have a cat. And let's let D be I have a dog. Let's let y be, I have a yard. I don't have a yard, that's the negation of I have a yard. I have a cat, that's the same one I started with. So it looks like I got all of them. Next, standard form. So I have either a cat or a dog. So 1. I know this is the conclusion because it says thus, so I have a cat is going to be the conclusion, whatever number it is. Premise number 1 is I have either a cat or a dog. You can translate in steps if you need to, but if it's simple, then feel free to just start. What you need to have is a key and a final argument in standard form that's in symbolic notation. If I have a dog, whatever comes directly after an if, there's no only if involved here, is the D. Then I have a yard, but I don't have, when something leads with a but or an and, that's sort of a transition word that tells us, and this is another thing that's true. We'll just cross the leading conjunctions out for notation, not for grammar reasons. I don't have a yard. That's the negation of I do have a yard. Okay, so here's my final argument in standard form. So let's make a truth table. How many atomic statements are there? 3. Let's put them in alphabetical order. C, D, Y. Now, immediately, I know how big my table is going to be. Why? How many rows for any statement or argument with 3 atomic statements? It's going to be 8. So, halvesies for the first column. And then we'll sort of cut that in half again. We'll do halvesies. And then cutting that in half again. And our goal is to get every possible combination of T's and F's that C, D, and Y could have. What could their truth values be? Here are all the possible cases. Okay, next we want to make sure we get every premise and the conclusion of the argument into our table. So we've already got the conclusion. There's only one negated statement. I usually do negated statements directly after atomic statements. And we don't do them just for fun. We only do them if we need them. This argument does have one, so we're going to need not Y. We also want to get C or D, and if D, then Y in. Since the parts of these 2 statements are all atomic statements, they're ready to go in the table, and it doesn't matter which order these 2 go in. We can put them in any order, because neither one is part of the other. C or D, and if D, then Y. And we'll want to label them. We've got P1, P2, P3, and the conclusion. All right, now let's complete the table. So not Y is the negation of Y. Wherever Y is T, not Y is F, and vice versa. So I'm just going to go through and do all the T's first. Try not to switch tasks, because that is a way to introduce errors. Everywhere there's a T is an F. Now everywhere there's an F is a T. C or D. There's only one case where this is false, when both disjuncts are false. So I need to look at the columns for C or D. On which rows are both disjuncts false? No, 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 no. Yes, yes. Okay, so here's where they're both false. Every other case, this is true. And finally, we've got a conditional statement. When is a conditional statement false? When the antecedent is true and the consequent is false. So now we are looking at the columns for D and Y. D is the antecedent. Luckily, they're in the same order. And so where is D true and Y false? Where is D true and Y false? Row 2 and row 6. and every other row, this will be t. Okay, now that we have filled in the truth table, we can use it to determine, or to prove, as this case may be, that the argument is valid. So if the argument is valid, what are we looking for? And what are we not looking for? We're not looking for the row where all of the premises and the conclusion are true. We don't care about that row. That's merely not a problem. We're ensuring that there is no row where the premises are true and the conclusion is false. So let's just start by looking for rows where the premises are all true. No, no, no. Here's one. No, 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 no. Okay, this is the only row we need to look at. What is the conclusion on this row? It's also true. So this argument is valid, not because we found the TTT row, but because we did not find a TTTF row. There is no case where the premises are true and the conclusion is false. It's impossible that these premises are true and the conclusion is false. If these premises are true, the conclusion must also be true. That is the explanation. This is all you need to write to justify that the argument is valid. This is the same thing as saying there's no counterexample row, there's no problem row. Any of those would be fine. Now let's use the proof method. Okay, so we just need this same argument here. I'm just going to copy it. And we're going to start by moving the conclusion out of the way. We're trying to derive C. Okay, how can we get C on its own line? We can either work backwards, I'm going to do that in my head, or just do anything you see, which will usually work in a simple proof, which this one is. So I want C. Where is C in my premises? It's up here in line 1. It's part of a disjunction. I want to get one of the disjuncts on its own line, so I'm immediately thinking DS. If I had not D, I could use DS to get C on its own line. So now I'm thinking I want not D. How do I get that? Well, where's D? D is the antecedent of a conditional, and Modus Ponens allows me to derive the negation of the antecedent of a conditional, which is what I want, not D, if I have the negation of the consequent. So I need not Y in order to apply Modus Ponens to this. And hey, I have it. So I've got a plan. Modus Ponens to get not D, oops, and then disjunctive syllogism to get C. Alternatively, just do whatever you see. Do you have any conjunctions you can take apart? No. We can make a conjunction of anything, but we don't want to unless we have a reason to. Can we apply Modus Ponens? Well, we have a conditional statement, but we don't have D, so no. Can we apply Modus Ponens? Again, we've got a conditional statement. Do we have the negation of the consequent? We do, so we can apply Modus Ponens. If we see a thing we can do, let's do it. All right, what else do we have? So still no conjunction, still don't need a conjunction. We already applied Modus Ponens. There are no other examples of Modus Ponens. Still can't do Modus Ponens. We haven't tried DS yet. We do have a disjunction. Do we have the negation of one of the disjuncts? Well, we don't have not C, but we do have not D. So that means we can get the other one. 1 for DS. And that's the conclusion, so we're done here. Okay, that completes the practice quiz. The number one way to study is to do practice problems without looking at any resources. The only resource I recommend having out is the rules written out in words, not the schematic, and only use them when you get stuck. You do enough problems and those rules will be very easy to memorize. That's the only thing that's worth memorizing and that's worth looking at as you're studying, is just the rules and knowing how they work. If you are applying a rule and you get something different from any answer or practice quiz, that's when you should reach out, because you're not understanding something about how the rule works, and how the rules work is everything in this material. Okay, so good luck studying and good luck on the upcoming quiz.